Медведев Жанович, можете начинать. Низкая пропускная способность сети написано.
Так, можно начинать, да? Хорошо. Dear participant of our dissertation council, quorum of our dissertation council is 9 members. Now, number of participants is 14. So, quorum is okay. So we can start. So our dissertation council works with specialty physics, nuclear physics, technical physics, physics and astronomy, radio engineering, electronics and telecommunications, material science and technology of new materials, thermal power engineering, physics, standardization and certification. So there is a proposal to start our work, and I think that there are no objections. So agenda of this meeting is a defense of thesis Bergaliyeva Saltanat Amangalievna on the topic standardization of recycled plastic materials for additive manufacturing for the degree of Doctor of Philosophy in the educational program, standardization and certification. The thesis work was carried out at the Department of Thermal Physics and Technical Physics of Physics Faculty of Physics and Technology, Al-Farabi Kazakh National University. Scientific consultants Bulugenova Saltanat, Al-Farabi Kazakh National University, David Sales Lerida, University of Cadiz. Official reviewers Байхожаева Бахткуль Uzakovna, Yenu, named after Gumilova, Vyoshin Sergeyevich is a Belarusian State Technology University. Official reviewers are here. The thesis work is submitted for defense for first time. All members of the dissertation council have materials of this work. So, who has any questions about agenda? If no, the agenda will be approved. To get acquainted with personal file of dissertation, the floor is given to the scientific secretary, Belisarova Farida Betultanova.
Dear members of the dissertation council, let me acquaint you with the materials received by the dissertation council for the applicant Bergalieva, and application addressed to the chairman of the dissertation council on the acceptance of the thesis for defense, thesis in hardcover and on an electronic media. Information about the doctoral student Bergaliyeva Saltanat Amangildinova, Kazakh, born in 1985, place of birth Almaty. She has a higher education in 2007 and she received a bachelor's degree in standardization, certification and metrology. In 2011, she received a master's degree in standardization, certification and metrology at Serikbayev East Kazakhstan State Technical University. Personalship certified at the place of study by the Personal Service of Al-Farabi Kazakh National University. A copy of transcript in 3 languages. Reviews of domestic and foreign scientific consultants, extract from protocol of the meeting of the department and attendance sheet, reviews of official reviews, certificate of the National Center of Science and Technology evaluation for anti-plagiarism, certificate of issuance of the thesis and annotations from the scientific library of the Al-Farabi Kazakh National University, extract from protocol of the meeting of the Academic Council of Al-Farabi Kazakh National University on the approval of the topic of the thesis and scientific consultants, copy of the order of the rector of the Al-Farabi Kazakh National University on the direction to defend a thesis, a list of scientific works certified by the Scientific Secretary of the Faculty of Physics and Technology of Al-Farabi Kazakh National University and their copies. Based on the results of the thesis work, 7 printed works were published, 3 of that were published in journals included in the databases indexed by Scopus, scientific databases, 3 in international journal, 1 in the journals included in the list recommended by the Committee of Quality Assurance in the field of Science and Higher Education of the Ministry of Science and Higher Education of the Republic of Kazakhstan. Materials of the thesis submitted by the applicant Bergaliyeva Saltanat comply with the approved rules of the preparation of the thesis for defense by the Committee of Quality Assurance in the field of Science and Higher Education of the Ministry of Science and Higher Education of the Republic of Kazakhstan, admitted to the defense.
Thank you. Well, do you have any objections or any questions about this information? If no, then the word is provided to describe the main content of the thesis to Bergaliyeva Saltanat, up to 20 minutes. Please start.
Thank you. Thank you. Can you see my screen?
Да, видно.
Okay, thank you. Okay, a little bit time. Oh, thank you, dear members of Dissertation Council. Today, I would like to present to you the results of my dissertation work to receive degree Doctor of Philosophy PhD in Educational Program Standardization and Certification by Industry. This thesis was conducted within agreement on joint international supervision between University of Kaznoy and University of Cadiz. And scientific advisors are Boligenova Sultanat Alihana and David Sales Derrida. The topic of the thesis is standardization of recycled plastic materials for additive manufacturing. So, production of any product, we need to have raw materials, then energy, technology, and labor resources. To receive good quality of products, we need to ensure the quality of these components. And standardization as normative regulation instrument can help us to receive a product of good quality. In the fourth industrial revolution, additive manufacturing technologies or 3D printing is recognized as a new innovative way to produce products. Additive manufacturing technologies, equipment for this technology is only 3D printer and computer, and it's easy to reconfigure production and to place it closer to consumer, avoiding transport costs and reducing air pollution. But additive manufacturing began to develop last 10-15 years, and therefore there is not sufficient data about use recycled plastic materials as a raw material. Thus, to reduce recycled pollution and to support the implementation of innovation in this work, we will discover and investigate the process of standardization of recycled plastic materials. The object of the study is the new material that had never been used in additive manufacturing. It's waste obtained after 3D printing from polylactate. Why do we choose exactly this polymer, not another? Because polylactate is one of the most famous polymers in additive manufacturing, and with increasing and more popular of additive manufacturing, it can be predicted that the waste from polylactate will be increasing too. And also we can talk about a low rate of degradation in the environment of polylactate and high production cost compared to petroleum-based plastics. So the purpose of the study is advanced standardization of the thermomechanical properties of filament and granules obtained from polylactate waste. To achieve this purpose, we need to set and to resolve 4 tasks. During the first task, we are going to determine the agent dynamic of polylactate and to answer the question which polylactate is suitable for recycling and which and which not. And in second task, we are going to check the thermomechanical properties and printability of the recycled polylactate, the age of which we determined in task number 1. And in task number 3, we are going to improve the quality of the recycled polylactate that we received in task number 2. And in task number 4, we are going to standardize the thermomechanical properties and the percentage of nanocomposites that we received in task number 3 and for further certification. So on this slide, you can see statements for defense. On every statement, I'm going to focus during my presentation. Task number 1, to standardize the accelerated hydrothermal aging process of the printed polylactate samples to determine the initial characteristics of the Derbis mixture. To conduct this experiment, we choose international standard ISO 188. But when we met closer with the requirements of this standard, we understand that it's very general. It can be used for any rubber and thermoplastic elastomers, and it doesn't regulate test parameters. So I proposed and documented standard of organization STGSCS 002, in which I wrote the techniques of accelerated hydrothermal aging of polylactate. And in this technique, I regulate temperature, humidity, and other test parameters for experiment. So for experiment, we printed 100 samples. Half of them we put in oven and half of them we put in climatic chamber.
and samples we took out after standardized period of time that you can see in table number 1 to correlate aging time, laboratory aging time with the real time of use. We use a simplified accelerate aging protocol that you can see in table 1. But the aging time of 8 and 16 hours we didn't include in our technique that we documented in standard of organization because it corresponds to very short period of time. So on this slide, you can see the results of dimensional measurements of 3 perpendicular sample sizes. And these results just confirm the theory of Kim that during aging, polylactate molecules are moving, but when it exposed to accelerate temperature and humidity, the movements are higher. And on this slide, you can see thermogravimetric analysis, and this analysis confirms the unstable nature of polylactate. The results of differential scanning calorimetry show us that glass transition temperature and melting temperature for both samples doesn't change too much. But if you look to the temperature of crystallization, it's decreasing with increasing time of aging. It can be explained by the decreasing in molecular weight. It's a well-known fact. And according to these results, we count the degree of crystallinity according to the formula 2, and the results of these calculations you can see on this slide. So degree of crystallinity for hydrothermal age samples increasing, but tensile strength at the same time decreasing. These two facts have correlation, and we can say that decreasing of hydrothermal age samples is because of anisotropy of crystal paths of polylactate. So statement number 1 can be formulated in the following way. Standardized process of accelerated hydrothermal agent in Standard of Organization STGSC 002-2023 polylactate for additive manufacturing accelerated hydrothermal agent test of 3D printed polylactate samples at 50 Celsius degree and 70% humidity for 1,344 hours result in a 33% reduction in tensile strength. The results of this experiment were published in the following article. So, task number 2, to verify the quality of polylactate filaments from real 3D printing waste with the addition of pure polylactate. In the previous experiment, we discovered that polylactate aged up to 1.5 years old is suitable for further mechanical recycling. So we collect this kind of waste, cut it, sieve it, and the fraction with size 1.25 millimeters were used to produce a filament in laboratory single screw extruder, and we produce 4 mixtures, the names and codes of which you can see in table number 3. And from all of these mixtures, we print samples for further analysis. Thermal analysis results shows that there is no changes in thermal stability and thermal properties of mixtures polylactate plus recycled polylactate. Also, we count degree of crystallinity, and here we know and we discover that degree of crystallinity and the percentage of recycled material, they are correlated. And with every percent of recycled material, the crystallization is falling down by 1.26%, and this linear trend has a regression of 0.92. The results of tensile strengths are presented on this slide. In this picture, you can see that the sample with highest percent of recycled polylactate has another type of rupture. It's more plastic, not rigid as previous, as another samples. And on the right, you can see the diagram that shows that with increasing the percentage of recycled polylactate, tensile strength is rising. It can be explained by the images of SAM. If you look to the figure number 14, you can see that the sample from pure polylactate has a big holes between layers, between printed, but the samples with recycled polylactate, these holes are too small. And we did some analysis with a bigger magnification, and we count the number of holes and its sizes, and we can say that with rising the percentage of recycled polylactate, the number and the area of the holes is decreasing. Statement number 2, increasing the proportion of secondary polylactite from 0 to 75% in a mixture with pure polylactite increases the tensile strength of printed samples from 44 to 52 megapascals. The results of this experiment is published in the following article. Task number 3, to improve the quality of 3D printed granules made from recycled polylactate by adding pure polylactate and titanium dioxide nanocomposite. Why we choose exactly titanium dioxide nanoparticles? First of all, because it's not expensive, it's not toxic, and it has potential to be reinforcing material. We did 6 mixtures, the name and codes of which you can see in table number 5. And in our previous experiment, we understand that printing from filament makes material to extra degradation. And in this experiment, we print our samples directly from granules, and we print samples in horizontal and vertical directions. The results of thermal analysis show that thermal stability with adding nanoparticles is increasing. And if we look to the degree of crystallinity for 2 groups with virgin material dust plus additive and virgin material plus recycled plus additive, they have the same tendency, is decreasing for these 2 groups. Scanning electron microscopy was carried out at 40 times magnification, and it doesn't show any difference between samples. Therefore, we decided to do some analysis on a bigger magnification, and here you can see the particles of titanium dioxide that were collected in agglomerations, but although they collected in agglomerations, but they homogeneous dispersed in the volume. ADX analysis was carried out to ensure that it's exactly titanium dioxide particles. Also, we counted the equivalent area of the titanium dioxide particles and do histogram of normalized agglomeration frequency. On this slide, you can see the results of tensile strengths, and on the left, you can see the results for the for the nanocomposites with virgin polylactic, and here with mixture. And here you can see that tensile strength is decreasing with adding additive. It's correlate with other results. But when we add the titanium dioxide nanoparticles to the mixture with recycled polylactic, we can see the increasing dynamic. And if we look to the first and to the last samples, you can see that they are almost the same with taking into account standard deviation. So statement number 3 can be formulated. Adding 18% of pure polymer and 7% of titanium dioxide nanoparticles to secondary polylactic increases the tensile strength and fluidity of FGF samples to match those of a standard sample during 3D printing. The results of this experiment was published in the following article. Task number 4, to develop a standard of organization for nanocomposite based on pure and recycled polylactic with titanium dioxide nanoparticles for material extrusion-based additive manufacturing. To develop a new standard, I did analysis of regulatory framework, and in sum, we can say that during existence of technical commissions and additive manufacturing, only 27 ISO standards was development, and only 7 of them is about polymers, but without specifying the type of polymer. So in the standard of organization that I developed, there are these sections. Especially in section classification, we classificate our nanocomposite in 3 types. In the section about technical requirements, we write about organoleptic and thermomechanical parameters. And these thermomechanical parameters will be tested by ISO, these standards, but these standards doesn't have techniques and methodology to count uncertainty. So in my standard, I include this methodology to count uncertainty. And statement number 4, standard of organization STGSC 001 2023 nanocomposite based on a polylactic and its waste with titanium dioxide nanoparticles for additive manufacturing. Technical specifications establish the percentage of pure and recycled polylactic and titanium dioxide nanoparticles in proportion 25-75-0, 22-75-3, 18-75-7 for further certification. So the results of my thesis can give me opportunity to do this. The following conclusions. First, after 1.5 years of operation in real conditions, the thermal and mechanical quality parameters of 3D printed polylactic samples decreased significantly. Next, the addition of 25% of virgin polymer to the polylactic waste leads to an increase in the tensile strength of used filament fabricated samples. Third, nanocomposites based on 75% recycled and 18% virgin polylactic with the addition of 7% titanium dioxide nanoparticles can have thermal and mechanical properties similar to those of the standard sample. And the advanced standardization of the upgraded nanocomposite with the percentage of pure and recycled polylactic and titanium dioxide nanoparticles in proportion of 25-75-0, 22-75-3, 18-75-7 for 3D printed is ready for further certification. The results of my thesis were published in 3 articles with high impact factor, and in 1 domestic journal, and in 3 international conferences. Actually, and additionally, it was documented in 2 standards of organization, and there is a certificate of implementation. Thank you for your attention.
Thank you very much. So questions? To have questions? To have questions? So I have one question.
I have a question.
Did you compare your standardization procedures to another ones? Because I think that additional technologies has a lot of base for standardization because it used for several various purposes. So is there any ready standard in your special considered field, and what was consideration in the, if you compare with already developed standards?
Okay, thank you for your question. Of course, I did an analysis of the based of standards. Unfortunately, there is only based of international standards, and no other standards were not developed. I can say that in my analysis, I divided these standards to the material for which you can use for metals, polymers, and other materials. And according to my analysis, we can say only that only 7 standards from 77 standards is about polymers. But it's very general standards. They are not talking about quality parameters of any polymer, and especially about polylactic. Therefore, it was need to develop a new standard.
Thank you. Any questions?
Yes, I have a question.
Please.
Hello, colleagues. Hello, Sultanat. Thank you, Sultanat, for your interesting presentation. And I would like to ask you about the main elements of novelty in your approach to standardization of the process of recycling of plastic materials. What maybe your input in this very important scientific and practical issue?
Okay, thank you for your question. In my opinion, the main novelty in recycling is that we know what kind of polymer we can recycle. Previously, nobody did this experiment, but I did accelerated aging, and this the results of this experiment gives me opportunity to recycle material that is suitable for recycling. And novelty about in standardization, it's before, as I said, testing of parameters we did according to international standards, but nobody, but there is no techniques for count uncertainty, and I developed these techniques. So, thank you.
Salta, hi, I would like to congratulate you for your fantastic work. I have a question about if you are with the result obtained, do you think that it is feasible to reduce 3D printing weights? Have you made an estimate of time and cost in order to see not only cost effectiveness, in order to see cost effectiveness apart from environmental benefits?
Thank you, Nuria, for your question. It's really interesting questions, and to count the effectiveness and economical effect, but it was not a purpose of my work. But I read a lot of another works of another scientists, and they said that it's the work that I'm doing is really will have a good potential to reduce waste and for recycling the waste from additive manufacturing.
And another question I can ask? Okay, well, do you think it's possible to reuse So you had a print with weights, part of weights, and you obtain samples, and then it's possible these samples again reuse. Do you think that taking into account the result is possible to reuse?
Yes, I think I don't think I'm sure because I have results of experiments. If you print your sample and its sample was aged not more than 1.5 years, you can easily to recycle it, but to get a better thermomechanical properties, you need to add pure polylactic and if you want to have a better quality, to put nanoparticles.
And the last question, in the last experiment, you have reuse polyactive, no PLD, but with waste, no, only with the reuse material, not with waste material. You did the last experiment. Is correct?
Yes, you understand very well. In a third experiment, we did a mutation of polylactic waste by reprinting it second time.
Okay, thank you.
Thank you.
Other questions?
А можно вопрос, да?
Да.
Можно?
Здравствуйте, Роза. Так, ну я вот читала в аннотации, да, вы получаете межслойное адгезию вторичного полимера. Я бы хотела уточнить, как вы улучшаете межслойную адгезию вторичного полимера?
Изучаем, извините, не поняла вопрос, изучаем межслойную адгезию?
Да, как улучшаете, не улучшаете.
Улучшаем.
Да,
Вот,
да,
смотрите,
да, улучшаем.
да, вот если мы, я здесь приводила сэм-микрографии, где у нас здесь видно, что у 100%, что у образца из 100% полилактида, вот здесь вот он представлен на рисунке 14, извините, мне тяжело переключаться с языка на язык, но вот здесь вы видите большие поры. Но когда мы добавляем переработанный полилактид, fluidity, текучая способность у переработанного материала, она выше. За счет этого у нас межслойная адгезия улучшается. Спасибо.
Хорошо, спасибо.
Well, I'm going to make another question. Why in the two first experiment you have used FFF technique and in the third experiment FGF technique? Why this the proposal?
Sorry, can you repeat what kind of techniques?
FFF for printing, for 3D printing, FFF technique in the two first experiment, and in the third experiment, you use the technique FGF, no? 3D printing.
Thank you. Yes. In second experiment, we use FFF and we print from filament. But when we receive the filament, it was the samples from it has a higher tensile strength, but it was very weak. We can just broke it, and therefore, and when we looked for it, we understand that because filament production, it's an extra process, and it makes influence extra degradation of our material. Therefore, we decided to switch our printing technique to FGF without producing filament. So by this step, we save our material from extra degradation.
So you think it's better to use weight material in the technique FGF instead of the FFS? So let me be another conclusion, no, of your work.
Thank you.
Thank you.
So, no questions? If no questions, we continue our meeting. Next step is scientific consultants' words. So, word will be given to domestic supervisor, Bölgen Sultanat. Please.
Thank you. In the period from 2018 and 2023, Sultanat Bergaliyeva studied at the educational program 8D750 Standardization and Certification by Industry of the Al-Farabi Kazakh National University at the doctoral program 8215 Energy and Sustainable Engineering of the University Cadiz, Spain. She successfully completed the both doctoral programs with a recommendation to defend a dissertation. The dissertation work is due to the study and standardization of thermomechanical properties of new raw materials for 3D printing from polyactid with for further certification. The results were obtained during the scientific internship of Sultanat Bergaliyeva in the laboratory of the University Cadiz. The dissertation is a completed scientific work performed at a high scientific level. I believe that Bergaliyeva Sultanat deserves to be awarded the degree of Doctor of Philosophy PhD by the educational program ED 0752 Standardization and Certification by Industry. Dear colleagues, I ask you to support the doctoral student in conferring an academic degree in the educational program AD 0752 Standardization and Certification by Industry. Thank you very much.
Thank you very much. So next floor is given to the foreign scientific consultant, PhD, Associate Professor of University of Cadiz, David Sales Larida. Please.
Салтанат, демонстрацию выключи.
Good morning, everybody.
morning.
Thank you for inviting me to this committee. It is a pleasure to be with you this morning. I haven't prepared any dissertation like a formal report, but I can give it with my I can improvise. So it was a real pleasure to have Miss Bergaliyeva in our lab. She is a very good scientist. She had developed their own methodologies from zero, because in our lab there were not previous results on using waste materials and try to recycle these materials. So she started from zero, which is a hard task, a hard duty, and she did it in a very, very well manner, carrying every single step, not only in the design of experiments, but also experimentally, and carrying the health, personal health, and of herself and the rest of the lab users, carrying the maintenance of the machines, which are sometimes difficult, and we really have a very good experience with Ms. Bergaliyeva. And we are very happy on the background that Saltanat Bergaliyeva had from their undergraduate studies, pre-doctoral studies. She could easily start with a new topic, different topic, because she had a very good, strong knowledge on physics, mathematics, and chemistry. And we really appreciate this from the students, and we really want to thank to you as a teachers of Kazakhstan University, KAZNU, because you are offering very good service and very good results to your pre-doctoral studies students, and this makes the scientific career more easier. Okay, so I really think that Saltanat Bergaliyeva deserves the doctoral diploma. She had 3 papers in one of the highest index impact index worldwide as polymers. It wasn't very easy. It wasn't easy to get the published papers because the reviewers were demanding high quality. But Saltanat Bergaliyeva answered every single requirement from the reviewers, and finally she got the 3 papers. So we had the international recognition of the work, which is important for our PhD students, and I know that Saltanat Bergaliyeva is ready to lead scientific research and to guide all their students, PhD students, in the future. So this is my report. Thank you very much.
Thank you very much. So next word is given to the official reviewer, head of Department of Standardization and Certification, Eurasian National University, named after Gumilova, Baykhozhaeva Bakhtgul Uzakovna. Please.
Good afternoon, dear colleagues. I will not read the whole text of my review. The whole review is presented on the KAZNU site. In general, the work is presented well. The structure of the dissertation fully reflects the topic. This was carried out at a high scientific level and covers not only the field of standardization, but also technical physics, nanomaterials, and materials technology, waste recycling, which is on the global and relevant problems today. The presented work has theoretical novelty and great practical significance. The results of the work are published in a very strong article. Thus, this is work performed on the topic. Standardization of recycled plastic materials for additive manufacturing is a completed research work. I believe that the thesis of the relevance of the problems solved and the quality of the results obtained in terms of their scientific and practical significance is a serious scientific research and meets all the requirements of the rules of awarding the degree of Doctor of Philosophy, PhD, of the Committee for Quality Assurance in the Field of Science and Higher Education of the Ministry of Science and Higher Education of the Republic of Kazakhstan. And it's also Bergaliyeva Saltanat Amangildinovna deserves to be awarded the degree of Doctor of Philosophy, PhD, in the educational program 8D 07502, standardization and certification by industry. Thank you for attention.
Thank you very much for your review. So next word is given to the official review, candidate of physical mathematical science, associate professor, head of department of physical and chemical methods of product certification, Belarusian State Technological University, Vetohin Sergei Sergeyevich. Please.
Dear Chairman and dear members of the Council, dear colleagues, the whole text of my review form was filled in and placed at official resource of KazNew. So I hope you permit me to represent the short version of it. In sum, the dissertation work of Sultanat Bergaliyeva, standardization of recycled plastic materials and additive manufacturing, is new, practically significant results were obtained in the above-mentioned field of knowledge. These include production and characterization of filaments suitable for printing by the field flow fractional method known as FFF, granules for mechanical testing by the fused granule fabrication of FGF method for polyactide. Recycled polyactide as well as form of mixture of primary and recycled polyactive with the addition of titanium dioxide nanoparticles. Based on the results of experimentally confirmed studies, the author has developed two standards of organizations. These standards is in front of the international standardization, so the achievement is very significant. The dissertation work was performed at high scientific and methodological level. The used methods are very high-tech, and use of them is also the good feature of this work. Thus, the thesis work performed on the topic standardization of recycled plastic materials for additive manufacturing is a completed research work. I believe that thesis on the relevance of the problem solved and the quality of the result obtained in the two of their scientific and practical significance is a serious scientific research, and it meets all the requirements of the rules of awarding the degree of Doctor of Philosophy of the Committee for Quality Assurance in the field of science and higher education of the Ministry of Science and Higher Education of the Republic of Kazakhstan. And its author, Bergaliyeva Sultanat Mugidinovna, deserves to be awarded the degree of Doctor of Philosophy in the educational program, standardization and certification. Thank you.
Thank you very much. So, next stage is so official reviews finished the speech. So now discussion. Who wish to get the floor? Who wish to explain his impression about?
Can I explain a
that?
little bit?
Yeah, please.
So thank you very much for a very interesting dissertation. I think what it is very, very important because it's talk about the recycled products and recycled materials and what can be usable for a long time. So it's also very important standardization of the properties what can show for users the quality of this material. So I think that this work are very, very interesting, and I invite to award the PhD for this for the student. Thank you.
Thank you very much. Is there any-
Can I say my opinion? Well, after review the work of Sultana Hatton, I think he had done a fantastic dissertation, well structured, with the right design of the experiment, well documented, and knowing that he had participated in each and every practical experiment that have required for the elaboration of the thesis. The results are published in important I don't know about the word. So in a very quick one articles. So I think that the novelty of her work and the important result she had obtained with the hard work she had done, I think that she deserved the degree of doctor in physical without the merit. Is my opinion. Thank you.
Thank you very much. So I think it's enough, yeah. Also, I wish several words. This dissertation is the first work in the field of additional technologies. So additive technologies is very important for future because all of your materials or all of production will be based on this technology. So that's why this is very important, and all of specialists in this field will be very, very high in quality. So that's why I ask you to support her, and I think that you will be very good scientist in the future. So now she approved that she is a specialist in this field. So thank you. So now she can make concluding remarks. Please, Saltanat, concluding remarks.
Thank you very much. First of all, I want to thank all the members of Dissertation Council for your questions and for your opinion to my thesis. Actually, I want to thanks my professors, my advisors, Bulygena Sultan Telihana and David Salis Larida. Actually, David Salis teach me how to do science, how to write articles. Thank you for you. And I want to say thank you to the Sergio Malina, who led me to use his laboratory of additive manufacturing, where I conducted all experiments. And I want to thank my Kazakh and Spain colleagues because on all steps of my way, I feel the support of anyone. And I want to say thank you to my friends and colleagues. Thank you.
Okay. So next stage is secret voting. So floor is given to scientific secretary, Ardavik Sultanna. Please.
Thank you. They are members of the Dissertation Council. A voting ballot has been sent to your mail. For secret voting, please vote.
Okay, let's vote.
Кто не проголосовал? Только 2 человека осталось. Еще один голос.
Я проголосовала.
Один человек не проголосовал.
Проголосовала.
Сергей Сергеевич, вы проголосовали?
Какая-то проблема с заполнением опять возникла. Сейчас пытаюсь сделать. Вот это тоже не хочет.
Ну, вы получили, да? На
Да.
почту дошло письмо. Хорошо.
Да.
Заполнить Google форму там.
Да, так
Его надо
требует подтверждения.
Ну у вас в тот раз тоже так было, да?
В прошлый раз пришлось новый аккаунт создавать. А все прошло. Почему сейчас не хочет? Так, теперь какой-то пароль требует. Куда он пришел, этот пароль, Бог его знает. Сюда не приходил. Естественно. Так, попробуем здесь.
У вас почта. Ну, вы, главное, получили, да, письмо Серега 49 собачка mail.
Да, я получил.
Смотрите на телефоне еще сообщение.
Ну, не могу открыть никак. Отправляет вообще на другие сайты меня.
Вы, наверное, в той почте не вошли в аккаунт. То есть, если у вас
Да
есть
вот
Google
пытаюсь
аккаунт,
войти, оно
попробуйте.
входить не хочет.
Входить не хочет?
Да, предупреждает о мошенничестве и не хочет.
Фаридаб Султановна, может, другую почту отправите?
Ну,
Если
Сергей
у вас
Сергеевич,
Mail.ru,
давайте
например, есть,
другую
Mail.ru
почту.
идите.
Нет, я все получил. Я все получил, и в прошлый раз все же это сработало.
Вы должны быть внутри аккаунта Google или там Mail.ru и так далее. Если вы внутри, тогда проблем нету. Наверное, вы вышли и не можете войти
Вот
обратно.
не могу сейчас
В аккаунт
войти.
надо войти вам сначала.
Да,
прежде
я
чем голосовать.
понимаю, но не получается. Оно не спрашивает меня, оно спрашивает пароль, который где-то.
Ну вот
находится?
он спрашивает пароль, который может. Вы сначала войдите в свой аккаунт в Гугле, в свою почту зайдите еще раз.
Вот и пытаюсь.
Выйдите и зайдите. Он считает вас не подтвердившую свою личность человека.
Ну, где у меня? Какая? Вместо аккаунта просто в поиск выбрасывает и все. Вот.
Ну,
Всё.
мне кажется,
Можете,
не
кстати, телефоном зайти. У вас есть телефон?
Да, конечно.
Если у вас телефон,
Я
телефоном зайдите, тогда
уже пытался и так, и так.
телефон тоже не идет?
Да вот не хочет идти.
Странно. Ну ладно тогда. Я думаю, что
Может,
испорченный
пароль
бюллетень.
пришел на телефон ваш как сообщение?
Проверим еще раз. Сообщение. Нет, сообщений нету. Сообщений нету. Сюда не могло прийти. Так, сюда не могло. Так. Так, теперь требует доказать, что я не робот. О боже.
Может, вы создадите Gmail почту? Так проще.
Ну вот, должен прийти сейчас. Вроде бы все сработало. Но не приходит.
Фарида Бексултановна, тогда давайте
Ну, не знаю, что делать.
испорченный бюллетень, потому что тут непонятно, когда уже можно сделать. Поэтому, если никак не получается, обычно телефоном голосовали. Если компьютер не получается, телефон работает. Обычно он все время сидит. Если у вас не получается, тогда будем считать, у вас испорченный бюллетень.
Давайте считать
Да.
испорченным.
Давайте считать
И
да,
пароль
испорченный
не
бюллетень.
принимает
Да.
пароль.
Ну, техническое же это тоже как бы...
Давайте.
Прошу
Хорошо.
прощения.
So to announce the result of secret voting, the floor is given to scientific secretary Фарида Бексултановна. Please.
I ask for permission to publish the results of the secret voting. All 13 members of the dissertation council voted. Voted. Results of secret voting awarding the degree of Doctor of Philosophy 13. Нет, 20. 100%. Boligenova Sultanat didn't vote because she is a scientific advisor. Sending the dissertation for revision 0. Sending a dissertation for defense 0. Refusal to award the degree of Doctor of Philosophy or Doctor of Profile 0. They are scientific by an electronic Excel document.
So, thank you. So, on the basis of secret voting, let me to announce our decision. So, dissertation council in the group of specialties, physics, nuclear physics, technical physics, physics and astronomy, radio engineering, electronics and telecommunications, material science and technology of new materials, thermal power engineering, physics, standardization and certification, Al-Farabi Kazakh National University. So we decide to give the degree of Doctor of Philosophy to Bergalиева Saltanat Amangildinova in the educational program 8D07502, standardization and certification. Congratulations. So according to the regulations, we need to accept conclusion of dissertation of work Bergalиева Saltanat. The draft of conclusion was sent to all of you. So let us take as a base this conclusion. If you have some recommendation, we will consider. I think that we will accept it. Please send to our scientific secretary. So do you agree to take as a basic of this document, send the document? Okay. So you can congratulate our dissertant.
Saltanat, my congratulations and best wishes.
Thank you.
I hope internet will be okay in the future.
Don't worry.
So,
My
many thanks for,
congratulations.
yeah.
Thank you.
Sorry. My congratulations to Saltanat and new scientific approaches in the future. Best wishes for you. And Happy New Year and Merry
Happy New
Christmas
Year.
to everybody.
So Merry Christmas for them. Okay, thank you very much for your work.
Merry Christmas.
Thank you.
So, okay.
Congratulations and very lucky in your next step of your life. You're very well. You're going done very well. I know.
Thank you.
Okay. Thank you very much for all. So now I wish to declare that our dissertation council meeting is closed. Bye-bye.
Bye.
Bye also.
Bye.
Спасибо,
you,
уважаемые
bye.
коллеги. Thank you very much. До
Thank you very
свидания.
much.
Поздравляем.
Поздравляю.
Спасибо большое.
Congratulations.
Спасибо большое.
Поздравляем, удачи вам.
Удачи вам.
А мне
Рахмет,
Google,
құрметті
Всего
әріптестер.
доброго.
мне Google
Ұзағына
напоследок
рахмет сізге.
сказал, что я вообще не я.
Сауболыңыздар.
И фамилия моя не
Сау
та.
болыңыз.
С наступающим вас.
Рахмет
Всего
бірге
лучшего.
болсын.
Қалжыңыз құтты болсын.
Рахмет бірге болсын. Сергей Сергеевич, спасибо.
Вам всего наилучшего.
Ага, Камиля Жүзбаевна, сау болыңыздар. Ага, сау болыңыздар.
Sağ olunuzlar.
Sağ olunuzlar.
Sağ olun.
Сау
До
болыңыздар.
свидания.
Почему?